Alright, we add, subtracted, and multiplied yesterday. So last operation that we have today is division. Two ways that we're going to learn today. We're going to use long division and synthetic division. Long division is just what it sounds like. It's when you learned how to divide when you were a little tot and you had everything underneath the house. I'll show you and remind you. And then synthetic division as well. The synthetic division, in my opinion, is easier. I like it more, but I can't use it every time. Long division you can use every time. So you got the go-to you can use every time, or you got the shorter way that you can use sometimes. Alright, let's see here. If I wanted to do 23, see how many times that will go into 598. Okay, just to remind you how you did this when you were taught. Then we'll look at the function, the polynomials. That's what we're actually dividing. So this is just a reminder here. So first off, 23. Will it go into 5? No. So will 23 go into 59? How many times? 23 will go, what's 23 times 2? 46. 23 times 3 is 69. So it's got to go 2, right? So I'll put my 2 up there. 2 times 23 is 46. Now subtract. 9 minus 6 is 3. 5 minus 4 is 1. And then you bring down the next term. So now will 23 go into 138? Yep. Got to figure out how many times. I know 23 times 3 is 69. 23 times 4 is 92. 23 times 5, 115. 23 times 6, 138. Is that for real? I mean, that's a problem that went in evenly without thinking.
Yeah.
I could never do that again. 6 times 23 is 138. That's the luckiest I've ever been. Alright. So remembering that long division from about the 6th grade there? Fun stuff, isn't it? Now we're fixing to throw x's and x cubes and x to the 5ths in there.
What?
Woohoo! Alright. We are going to divide. Here we go. We are going to divide 2x to the 4th plus 3x cubed plus 5x minus 1. We're going to divide that by, so there'll be a slash there, x cubed plus, hold on, that's supposed to be an x squared. See, I'll mess this up by writing it wrong. X squared plus x, 3x plus 2. Alright, so what we're dividing by, that thing on the bottom, is what goes outside the box. Now, when I start writing this stuff, I hope you haven't written it yet, because you got to pay attention to this stuff. Whatever your highest power is, when you're using division, long or synthetic, that we'll look at here in a second, whichever one you're using, whatever your highest power is, you got to have every power below that. So if I go to what's outside the box, 2, 1, nothing. So that's good, right? I've got every power. My degree is 2. Then I've got the first power, and then I got no power. So that one's good. So I don't have to mess with it. That's going to go outside the box. What you're dividing by goes outside the box. All right, inside the box, I got 4, 3. There's nothing to the second power in there, is there? So when I write that inside the box, I've got to include a 0x to the second power. Okay, so here we go. 2x to the 4th plus 3x cubed plus 0x squared. 4, 3, 2. I've got a 1 plus 5x and then minus 1. Okay, sometimes you'll have to put those zeros in if you don't have every power. Don't forget that. Alright, so now it's not as difficult as if it were numbers. It's just more confusing looking. But what we're going to test here, we're going to take the first thing out here and see how many times it will go into the first thing in there. Okay, so what I'm asking myself is, what do I need to multiply x squared by to get a 2x to the 4th? You know it's got to have a 2 in it, right, Caitlin? So 2 times x squared make 2x squared, but how would I get it to be an x to the 4th? good, good. So I'm going to multiply by 2x squared. Now you can put the 2x squared anywhere on the top that you want to. I always put it over, it's just whatever it is, so 2x squared is going to go over the x squared. Okay, and we got that because we asked ourselves the stuff in the yellow. X squared times what will give me 2x to the 4th. Now I got to take that and I got to distribute it to everything outside here. Okay, so 2x squared times x squared is 2x to the 4th. And these are going to line up as like terms. 2x squared times 3x, 6x cubed. Got that? All right. And then 2x squared times 2, 4x squared. Right? Okay, good there? Now, just like on the number problem when you were a little taught, you're going to draw a line and subtract. 2x to the 4th minus 2x to the 4th is nothing. 3x cubed minus 6x cubed is negative 3x cubed. 0x squared minus 4x squared is negative 4x squared. Now, after we got done subtracting on the little tot problem, what did we do? Did we bring something down? Yep. So I'm going to drop that 5x down, plus 5x. Not yet. We're going to have to go another step to get there. Just drop one thing down at a time. That's a good question. Just drop one thing down at a time. Now, we started this thing off by saying x squared times what gets me 2x to the 4th. We're going to do the same thing here. We're going to say x squared times what gets me negative 3x cubed. So x squared times what would give me negative 3x cubed? Good. You know, you've got to have a negative 3, and then to get an x squared to an x cubed, you've got to have an x. Right? Now notice on the top we had an x squared, now we got an x to the 1st, so those are going down. Right? Alright, take that negative 3 now, just like we did before, and distribute it to all three of these dudes out here. So negative 3x times x squared, negative 3x cubed, negative 3x times 3x, negative 9x squared, and negative 3x times 2, negative 6x. Now we're going to subtract. Be careful with your signs here. Negative 3x cubed minus negative 3x cubed, that's nothing. Negative 4x squared minus negative 9x squared, 5x squared. 5x minus negative 6x, (11x). We're done subtracting. Is there anything up top that I haven't brought down yet? Yeah. Yep, so we got to drop that minus 1 down. And now we're doing the same thing again. X squared times what will get me 5x squared? Just 5. So we got to take that 5 and distribute it to all three of those dudes. So 5 times x squared, 5 times 3x, 5 times 2. Okay, we're subtracting. 5x squared minus 5x squared is nothing. 11x minus 15x. Negative 4x. Negative 1 minus 10. Negative 11. Now, do I have anything else left to bring down? No. So, what's this thing down here that's left over? Has a name. A remainder. Good, David. And when you were a little taught, if you had like 3 remainder 6, you would just write 3R6. We don't get to do that anymore. Our remainder, to write our answer, here's how we write our answer. We're going to take what we had on top, so our answer is 2x squared minus 3x plus 5. And now since my remainder, I'm going to say plus, and I'm going to put my remainder over, so negative 4x minus 11 over what I divided by. And that's how you always have to write your remainders in Algebra 2. Your remainder over what you divided by. It's supposed to be an 11 in there. So that whole WAD is your answer. Wasn't really hard, just a lot of steps, yep. Alright, you got what you need on that, so we can try another one? Alright, let's try another. Oh, Gracie's got sharpen her writing. X cubed minus x squared minus 2x plus 8. I want to divide that by, use the other division sign this time. X minus 1. Alright, so this one's actually a little bit easier than the first one. We do the hard stuff first in here. Is what's going to go outside the box? Still going to do long division on this one. X minus 1. And do I need to put a 0 anywhere in that? No, makes them dry because it's x to the first and then a constant, so nothing to add zeros in on that. Okay, so inside the box, do I need to add a 0 anywhere? No, because you got 3, 2, 1 constant, so you got everything covered. So x cubed minus x squared minus 2x plus 8. Alright, so we ready? First thing outside is an x. X times what gets me x cubed? X squared. So you put an x squared on the top. Now I've only got two things out in front. It's a binomial out there, so I only have to multiply x squared twice this time. X squared times x is x cubed. X squared times negative 1 is negative x squared. Get ready to subtract. This one's cool. X cubed minus x cubed is nothing. Negative x squared minus negative x squared is also nothing. So I got nothing there. So go ahead and do what Caitlin said and drop down that negative 2x. Now, this is a case, and this is a weird one, but this is a case where I'm also going to go ahead and drop down the plus 8. Why? Why do you think that? Good, because whatever I put up here on the top in a second, I'm going to have to multiply it times two things, right? So I need to have two things down here to put it underneath. So I'm going to go ahead and drop the plus 8 now as well. So and that could be a mental note for you. How many things you have down here is always going to be the same amount of things you have out here, right? Okay, so x times what gives me negative 2x? Negative 2. Distribute a negative 2 to everything. Negative 2 times x is negative 2x. Negative 2 times negative 1, so positive 2. Subtract. Negative 2 minus negative 2 is nothing. 8 minus 2 is 6. So for my final answer, I don't have anything else to bring down, so I know I'm done. So my final answer is what I have on top plus my remainder over what I divided by.
So if you don't have any remainder, it would just be x squared minus 2.
Uh-huh. Yep. Alright. I'm going to do that same problem now with synthetic division. You got what you need off that page? That first two have been long division. Now I'm going to do that same problem with synthetic division. It takes less than long. You've got enough room there. Alright, let me copy my problem again. It was x cubed minus x squared plus 8 divided by 11, just x minus 1. Alright, synthetic division. This is going to be totally new for some of you, so it's confusing in the beginning, but it is way easier. Your box on synthetic division is upside down. That's the first thing. Box is upside down. Good thing about synthetic division is that it does not involve variables. It's only the coefficients, so it's only numbers. So that's easier for most of us, just the numbers. So inside the box, instead of writing this whole thing, I'm only going to write the coefficients. Now, just like long division, if I'm missing something, I got to put a 0, but we're not missing anything here. So I've got a 1x cubed, I just put a 1. I've got a negative 1x squared. I've got a negative 2x. And I've got an 8. And you need a little bit of space like I left there. We're going to put other numbers in there in a minute. Now, what goes outside the box on synthetic division is what tricks people sometimes. If they've given you a factor, and that's what this is, this binomial, x minus 1, you have to solve that factor. So that means a positive 1 is going to go outside the box.
Sorry, I got lost. Okay. The numbers inside the thing, where are those from?
A 1x cubed, a negative 1x squared. It's just the coefficients. Now we're going to do some synthetic division later, maybe this period, maybe later in the week or next week, where they just tell you to divide by 3. If they just tell you to divide by 3, you just put a 3 out there. But when it's in a binomial form like that, you have to set it equal to 0 and solve. Okay? So everybody good on, we got a positive 1 out there right now? Alright, so start synthetic division. You have to get the ball rolling somehow. You're going to drop the first number in your box all the way down below it. So I just drop that 1 all the way down. Now from here, all we do is multiply and add. Multiply and add. We multiply what's below times what's outside. So 1 times 1 is 1. And I'm going to put it underneath the next number.
So where's that?
Oh, hold on, you're already ahead of me. Okay, we did the multiplying. Now I said add, right? So add right there. Negative 1 plus 1. And now multiply. 0 times 1. And then add. Negative 2 plus 0. Now multiply. Negative 2 times 1. And then add. 8 plus negative 2. So you were always multiplying what was outside the box. We had to drop this one down to get the ball rolling. You multiplied outside the box and then put it inside and add it. So that gave you a new number to multiply outside the box, put it inside and add it. That gave you a new number to multiply outside the box,
Wait, what did you add?
put it inside and add it.
8 plus negative 3.
Uh-huh. Alright, now we're done. We just got to know how to write our answer out of this. This started off as x cubed, and we divided it by x. If I had an x cubed and I divided it by x, what's the highest power of my answer going to be? And so this is an x squared. 0x, negative 2, remainder. So you've got x squared. You can put the 0x, I'm just going to leave it blank, minus 2. Remainder over what I divided by. Same exact answer we got with long division, isn't it? Look at your long division problem. Isn't that what we got?
Yeah.
Same answer. Grace.
One more time, how do we know that the 6 was the remainder?
In synthetic division, the last spot will always be the remainder. But it's x cubed divided by x is x squared, and then it just goes downhill. Squared, first, constant, remainder.
And it could, the remainder could be 0.
Uh-huh, yeah.
How do you know?
I'm going to tell you about that, but we'll do it now. Since you have synthetic division, you can only do when it's a first power, when you're dividing by something to the first power. It's easiest when it's a 1x or y or z, whatever, to the first power. It's because you've got to be able to solve it for x. If it's a squared or something like that and you solve it for x, you can have more than one answer. So you wouldn't know what to put out here, right? So it's got to be an x to the first power, and most of the time I do it if it's just like a 1x to the first power. If like that first one that we did, whoops, wrong button. This one that we did, it would have taken me longer to solve that for x than it would have just to divided it, because I'd have had to, that's a quadratic. I'd have had to use the quadratic formula. Then that would have given me 2 answers. How would I have known which of the 2 answers to put out there? So I couldn't have done that. But, all right. Let's do another. Another, David, another. Kevin doesn't have horns.
They're not supposed to be so.
That's cool. Never seen that happen before. Never seen that happen before.
How cool is it?
Negative x cubed plus 4x squared plus 9. We're going to divide that by x minus 3.
So we could do some.
Okay, now, once we get both of these covered, you can do whichever way you want to. There are times when it has to be long, but for right now, since synthetic is what's most new for you, and you can use synthetic on this one, that's what I'm going to do. Okay, so let me get my upside down box drawn. Now we're filling in coefficients. I've got a negative 1x cubed. I've got a 4x squared. Check this out. 0x. Did you see that? Don't forget those zeros, and then a constant of 9.
Oh, because it has to go in order.
Yep, gotta have all the powers. 3, 2, 1, 0.
So if you forget the 0, you'll get one.
Yep, it's gonna mess it up. Yep. That happens a lot in the beginning. Since the highest power was 3, 3, second power, first power, no power. Yes, ma'am. Alright, what's going to go outside the box on this one? 3, because you would take x minus 3, set that equal to 0 and solve, so 3 is correct for outside the box. We get the show on the road by dropping the first number all the way down, because we got to have something to multiply by. So now I got two things outside. I multiply those. Negative 1 times 3 is, yes? I set the factor equal to 0 and solve.
Are you always going to add?
Yes, it's always multiply, add. Alright, so I got negative 1 times 3 is negative 3, and I put that in the next spot, and then I add. 4 plus negative 3 is 1. So now I got a new number outside. 1 times 3 is 3. So I put that in the next spot to add. 0 plus 3. Now I got a new number here to multiply. 3 times 3 is 9. Put that in the next spot and add. 18. Okay, so these are the coefficients of my answer. This negative 1 is going to be negative 1x to the what? Good. Good, David. Squared.
I thought the 3 went with that negative 1. That's good.
You thought the 3 here, is this the 3 you're talking about?
Yeah, I thought you dropped it down.
No, this row here is your answer row.
So you didn't drop the 3 down? You just dropped the negative 1 down?
It just looked the same here because they're both ones. That might have been what confused you. Yeah, it's that row. Okay, now, David, the x squared is right. Okay, a couple ways you can look at that. The way I said it on the last problem was x cubed divided by x is what? And that's x squared. That's an easier thing that I sometimes do, just common sense. I'm always going to be on synthetic division. Only on synthetic division. I'm always going to be, my answer is 1 power less than what I started with. I start with x cubed, my answer's got to be 1 smaller than that. And then they just go downhill from there. Negative x squared plus 1x.
Is it always 1 down?
Yes. Plus 3. My remainder over what I divided by. Grace.
So what's the reasoning behind it's 1 power down?
X cubed divided by x.
Oh.
We took 1 power out, so it'll be 1 power down. That's why I said on synthetic, because long division, if I chose long division, it was probably bigger than an x to the first if I chose long division, so that wouldn't apply on that.
How would you do it if
You could take 2x minus 3, set that equal to 0 and solve. Now that's going to get you a fraction to go outside the box. 2x would equal 3. So x would equal 3 halves. So you put 3 halves outside there. You could do that. I don't know if I would or not. I might just go ahead and do long division, but halves are easy fractions, so that wouldn't be too bad to do. Got like 17/19 or something. I wouldn't be wanting to do that. Susanna, don't you cry for me. From California. That make you chuckle there, Sydney? Good singing about you. Oh, Sydney, oh, don't you cry for me. You're going to try this one by yourself. All right. Inside the box, there's a spot that needs a 0 in it. See if you can get that one by yourself. Go. Alright, first thing to check, if you're not sure, is make sure you set it up right. Everybody got theirs set up good? Okay. Now to start the thing rolling again, you just drop that first number all the way out. So you drop the 2. Now we multiply. 2 times negative 3 is negative 6. And then we add. 0 and negative 6 is negative 6. Gets me a new number to multiply. Negative 6 times negative 3 is 18. I add. Negative 1 plus 18 is 17. That gets me a new number to multiply. 17 times negative 3, I think is negative 51. Okay, I add and I get negative 58. So this started off as 2x cubed, which means my 2 is going to be a 2x squared minus 6x plus 17. Now I'm going to do something a little bit different this time. I've been always writing my remainder as plus, and I could still do that. I could write plus negative 58 over x plus 3. That's the same. Plus a negative is the same as just minus, isn't it? Don't change it if you wrote it the other way. It's still the same. Just want you to see there's other ways of writing stuff. Plus minus is the same as just minus, right?
Mm-hmm.
So you could write that either way. Good job. Good job. Good job. Good job. All right, the last bullet up there on our thing, the remainder theorem. The remainder theorem is still using synthetic division. So if I had a function that said f of x is equal to 5x cubed minus x squared plus 13x plus 29, and then it says x equals negative 4 over here. Directions for this says use synthetic division to evaluate when x equals negative 4. And the reason it's called the remainder theorem is because our answer to that is going to be what we get in the remainder spot. It's crazy. I don't know how they came up with it, but it works. So we can do it. Now, let me first off tell you that there is another way that you already know of how to evaluate that. If x is, we're not going to do this, but if it wants to know what does this give me when x is negative 4, all you would do is plug a negative 4 into all the x's and solve. That's one way. We're going to get it using synthetic division right now. It's actually pretty easy both ways. I think I can do it faster with synthetic division just because it's easy to multiply and add real quick. Here I'd have to do powers and then multiply the, either way is not bad. Alright, synthetic division, you got 5x cubed, a negative 1x squared, 13x, and a 29. So I didn't need any zeros. Now here's where it's a little bit different. This doesn't say x plus or minus anything. It just says x is negative 4. So you don't have to solve that, it's already solved. So just the negative 4 goes outside. Do you see the difference in that in the last problems? That's where people will get confused. They'll put the wrong sign out there sometimes. Alright, so I'm going to go through synthetic division now, and my answer is going to be, this is why it's called the remainder theorem. My answer is going to be whatever I get in the remainder spot. So drop your 5. 5 times negative 4 is negative 20. I add and get negative 21. Multiply and get 84. I add and get 97. I need help here. 97 times negative 4 would be 100 minus negative what? 388. Negative 388. I add and get negative 359. 59. That's your answer. So what that tells me is that if I'd have plugged a negative 4 in for all those x's up there and worked it out, I'd get a negative 359. And you would. That's it. That's all you do on that.
What was the direction for that again?
So evaluate when x equals negative 4. So it'll just say evaluate.
So we could do it either way.
Yes, you could. You could. That's not giving the same result. So
Will that work every time?
Alright, I'll let you do one of those by yourself now.
You want to do it this way?
I prefer while we're still practicing, yeah. Alright, f of x is equal to 5x to the 4th plus 2x cubed minus 20x minus 6. And I want you to evaluate when x is 2. Okay? You need a 0 in that synthetic division box. Do you see that? Okay, put the 0 where it goes. See if you can evaluate that and go.
Dang, got it.
That's fine.
I missed.
Did I get anything yet?
Yes, ma'am.
Alright, let's see if I get what I got. Hope so. That means you're smart. Alright, I got 5x to the 4th, 2x cubed, 0x squared, negative 20x, and a negative 6. Did I put a 2 or a negative 2 outside the box?
2.
Just a 2. Drop your 5, multiply, 5 times 2 is 10, add 12, multiply, 12 times 2 is 24, add 24, multiply, 24 times 2 is 48, add 28, multiply, 28 times 2, 56, add and get 50. That's it. Nothing to it, Buttercup. Are you alright? Now you can write that your answer in some fancy ways. Since we evaluated that when x was 2 and this was f of x, I could say f of 2 was equal to 50. You know, if you see that, that's what that would mean. So it doesn't make me a difference if you write it that way or not, because you see that somewhere, you'll know what it's talking about. Alright? Good deal. That'll be a wrap today.